Hey everybody, and welcome to Chapter 11, which is all about area. And this video is focusing specifically on the area of squares and rectangles, which is why I thought it would be a good flipped video after your test. So before we get into examples, let's go through what the formulas are for the area of a square and rectangle and focusing on what type of height you must have. So the area of a square and rectangle are really the same formula. Area is base times height. Or you could think of the area as length times width, and that's the same for a rectangle as well, base times height, or length times width. The one that you're going to be hearing me say in class a lot more is base times height. So I would definitely write those down for both situations. But beyond those two possibilities, I'd like to also point out for a square that you know that all sides of a square are equal. So if I call all the sides S, you could think of the area of a square also, rather than just base times height, as side times side, or even better, just side squared. So a square technically has three formulas that could work for it, and a rectangle has two formulas that could work for it. And specifically, when you're finding area, there's something that has to be true about your height. Your height must always be perpendicular, aka your height must be an altitude in order to truly find the area of a square, rectangle, or really any shape as we keep going through this unit. So with that in mind, let's take a look through some examples. I want to focus a lot on the ones that you're trying to find the area of a shaded region. So for instance, in this first example, you're trying to find the area of this inside rectangle. And so one way that you could view this problem is you could find the area of the large rectangle, and you could subtract the area of the smaller rectangle. Think of it kind of as a donut, that you're finding the area of the whole thing and then removing the inner piece. So to find the area of the large rectangle, it's base times height, and then the area of the small one is also base times height. So the large rectangle, the base is 48 meters, and the height is 22 meters. The smaller rectangle, the base is 12 meters, and the height is 7 meters. 48 times 22 is 1,056. 12 times 7 is 84. So the area of my shaded region would be 972. You need a unit, and because if you think about area, if you're doing base times height, you're doing meters times meters. So your unit would have to be meters squared. So there's your answer for the first example. Second example, it looks like a staircase, and we're trying to find the area of the piece that is remaining. So there are two ways that you could view this question. The first way you could find the area of this inner shaded region is you could pretend like the entire thing is really a rectangle, and then you could subtract out these two rectangles that don't exist, or you could split this shape up into three rectangles. So I will do method 1 and method 2. So let's say we view method 1, that we complete the entire rectangle and then subtract out the two pieces that aren't there. So the area of the big rectangle would be base times height. The base of the large rectangle would be 6 plus 8 plus 7, which would be 21. The height of the rectangle would be 2 plus another 2 plus another 2, or 6. So the area of the entire rectangle will be 21 times 6, which is 126 units, but then you'd subtract off both rectangles. This rectangle has a base of 8 and a height of 2. This rectangle has a base of 7 and a height of 2 plus another 2, or 4, which is written here. So 126 minus 16 minus 28 would get you an area of 82 inches squared. If you would prefer another method, you could look at this shape as different rectangles already. Like you could draw in these two segments and do rectangle plus rectangle plus rectangle. So if we did method 2, which I'll fit in here, if you wanted to find the area of this first rectangle, the height, and I'll write it right on the picture, the height of this rectangle would be 2 plus 2 plus 2, or 6. So this would be 6 by 6, or 36. This rectangle would be 8 by 4. So this would be 32 inches squared. And this rectangle would be 7 times 2, or 14. So if you added up 36 plus 32 plus 14, you would still get an answer of 82 inches squared. The next ones I would like for you to try on your own. This one, think of finding the whole rectangle and subtracting out the two pieces. And this one, you want to find the area of this square. So please pause now and try these two examples. I will have the work when you come back. Alright guys, so please check your answers. The first example, I did the large rectangle minus the medium minus the small, and my final answer was 147 meters squared. And the second one, I really used area equals side squared, took 1.25 squared, and rounded a bit and got 1.56 centimeters squared for my area. The next example, a rectangle is 6 meters longer than it is wide. All right, so 6 meters longer than it is wide. The area of the rectangle is 315 meters squared. We want to find the length. So if you think of a rectangle as length times width, we can think of it as L times W, but it says that the rectangle is 6 meters longer than it is wide. So that means that the length is 6 units larger. So we could also call the length the W plus 6. So let me do that in a different color. So if you think of it as the width plus 6, then what you could do is use the W and W plus 6 and set that equal in some way to the area. Because we know that length times width, or base times height, is equal to the area, we really know that W plus 6 times W equals 315. If you distribute that W in, you would get W squared plus 6W equals 315. Looks like a factoring problem. We subtract the 315 and equal that to 0. We could see if this factors. So let's see, two numbers that multiply to be negative 315 and add to be 6. That would be 21 times 15, positive 21, negative 15. So my two answers would either be negative 21 or 15. But because length can't be negative, negative 21 is out, which means my width has to be 15. But my goal is to find the length. I know that my length is 6 bigger than my width, so my length must be 21 meters. Last examples here. We are again finding the area of the shaded region. And yes, there is more than one way to do these problems, and you can do them however you would like to do them. My suggestion again would be pausing and trying these on your own first, and I will come back with my answers and my work and explain the way that I did it. As a suggestion before you start this one, I would maybe suggest completing this and thinking of the entire rectangle minus the inner part to find the shaded. And this region, again, you can do this either way, but again, you might want to consider the entire square minus the parts that you don't need to find the shaded region. So please pause now and try these first, and again, I will come back with my work. Alright guys, so here are my final answers for these two. What I did for this one was I took the entire rectangle, which was 30 times 24 base times height, and subtracted the inner square it turned out to be, which is 20 by 20. So I got my final answer to be 320 millimeters squared. Feel free to pause and look at my work if you'd like to. My answer for the second example, I knew that the entire side of each, actually ended up being a square here, each of these were 14. So base times height of this square, or side squared, would be 14 by 14, or 196. And then I knew I needed to subtract out the four white squares, each of which had an area of 25 meters squared. So what I did in terms of an equation here is I did base times height minus 4 equal squares of an area 25. So I had 196 minus 100. So my final answer was 96 meters squared. All right, next class we'll be doing area of parallelograms and triangles, as well as going back to more squares and rectangles. Again, I hope this video was helpful. and given you a chance to try the problems first. I hope that was useful as well. All right, guys, thank you guys for your attention, and see you next class period.